All right, fellas. Well, a little bit late. I just got back from the hardware store. Oh, well, that's good. That's what I needed to hear, even though I have system sounds muted. Hey, I'm just gonna get right into the presser. Um, if you guys hear stuff going on in the background, because of course, uh, you know, uh, people working on my office, doing work that I can't do, are here. So, if you hear some work in the background, that's how it goes. Sorry. Of course it was timed that way. Here, so let's jump into it. Let's listen.
All right, good afternoon.
Oh, sweet.
Thank you, Catherine, and welcome to everyone who is joining us today. It's particularly exciting for me to talk to you on the eve of Artemis 1. As you all know, in just a little over a week, hopefully next Monday, the first flight of the Space Launch System, the SLS, and the first lunar orbital flight of Orion will take place, setting in motion a series of missions that will return people to the surface of the moon for the first time in over 50 years. And I know, well, many eyes, including mine, by the way, hands, arms, cameras, iPhones, they're all focused on this beautiful vehicle in Florida. If you haven't seen it today, take time to look at it because it is quite a sight. But today, my science and technology colleagues who are on the line with me today, and I and others throughout the agency, we've been focused on what we're going to do on the future missions. And that leads us today. Today, Jake Bleacher, Sarah Noble, Prasanth Desai, and I are here to announce some really exciting news. The 13 specific regions around the south pole of the moon that we have selected as potential Artemis III landing locations. Artemis mission planners, people that work with me, NASA's Human Landing System program at the Marshall Space Flight Center, and their prime contractor, SpaceX, have worked very closely with our agency's scientists and technologists to identify these 13 regions that you're going to hear more about today. And what you're going to hear more from our other speakers that all of the regions that we have selected, all 13, have both utilization value. What that means, they're of value to the scientific community and the technology community. People want and need to do things there, as well as meet the Artemis mission planning constraints, which can be challenging. This will be the first time we will land a human lander at the South Pole. It will be the first landing of a Starship, so we have to pay close attention to the engineering and safety constraints of the mission and the vehicle. First, some background on our plans how do we get from today to that Artemis III landing? Well, it all starts in Florida a little over a week from now. You know about that. Artemis 1, the first SLS flight, and the first Orion lunar orbital flight will demonstrate key capabilities of both of these vehicles. And it's extremely important. It's a very thorough, very rigorous test that will check out all the systems that are important to put humans on for the first time. About 2 years after Artemis 1, in 2024, we will launch Artemis 2, which will be the first time people will ride aboard Orion, and also the first time that people will return to the moon since Apollo 17, an extremely important flight that will set the stage for the follow-on Artemis mission. About that time, shortly thereafter, SpaceX, our contractor for the uncrewed for the human landing system, they will perform an uncrewed with no people on it test of the HLS. That will be extremely important. And all of this culminates in late 2025 with our Artemis III flight, which will be our first Artemis crewed lunar landing, marking the first time a woman will walk on the moon, and also the first time we humans have visited the South Pole region.
It's not that far away, dude.
We've talked about this before. You're going to hear more about this today, but we're going back to the moon for several reasons. First of all, for science discovery, to learn more about ourselves, more about where we came from, planetary processes. We're going to advance technology. Things we'll do just in creating the vehicles and systems that support people, but also things we'll do specifically on the surface of the moon will advance technology, help all people. And also, we're using this experience to prepare for a trip to Mars. We're going to demonstrate the systems we need. We're going to learn how to adapt, protect, and take care of the human body. And we're also going to learn how to use lunar resources to get to Mars. Our Artemis 1 and 2 missions will demonstrate the Space Launch System, Orion, our exploration ground systems, and also the space communications and navigation networks we need to do this mission. But to accomplish the actual lunar landing, we will add 2 more key elements before Artemis 3. One I mentioned briefly, the human landing system, and also our exploration spacesuits. SpaceX, as I mentioned, will provide the Starship, what's known as the Starship Lunar Lander, and they are very much into the development of that lander as we speak. And we, NASA, just recently selected 2 companies, Axiom and Collins, that will build spacesuits. Now, when we selected the company, there are actually 2 different suits we'll be developing via this contract mechanism, one for the International Space Station, and one we will use on Artemis 3 when we people walk on the moon for the first time.
It's Mark Karasich.
Talk a little bit about the Artemis 3 mission. It's different from the Apollo mission. In the Apollo mission, the elements we needed were all launched on a single Saturn V launch vehicle. And in our architecture, it's a little bit different. If you've seen the Starship concept, the SpaceX will actually launch a fuel depot that will orbit the Earth, and then they will launch tankers, which will fill up the fuel depot. And when there's the amount of fuel we need in Earth orbit, the actual Starship that will take people to the surface of the moon will launch from the Earth and will fill up with gas, if you will, in Earth orbit. It then travels to the moon, and it enters the orbit that we'll use to conduct our lunar operations from. It's called the Near Rectilinear Halo Orbit, NRHO. We use that acronym. It's a very stable orbit around the moon that gives us a very long look over the South Pole where we'll be landing. Once we've confirmed that the Starship is there and ready to receive the crew, then we will launch SLS on Orion from the Kennedy Space Center. Orion will travel to the moon and dock with the Starship in the NRHO orbit. We will spend a couple days docked, and then 2 of the crew will transit from Orion into the Starship, undock, and land on the moon.
2 crew in a Starship,
on the surface of the moon, we'll spend 6.5 days. The crew will do work both inside and outside the HLS. Outside, we'll be doing field science, deploying instruments, collecting samples to bring back to the Earth. Inside, we will do various observations of the human system and how they're adapting to the lunar gravity. At the end of approximately 6.5 days, the Starship will lift off from the surface of the moon, rendezvous with Orion in the NRHO. We will transfer the crew back into Orion, and Orion returns and lands in the ocean off the coast of San Diego, just like we will do on Artemis 2. The subsequent missions we're flying are going to build on what we accomplished during this flight. Right after Artemis 3, we'll begin the buildup of the Gateway. The Gateway, as you know, is an outpost in lunar orbit that we will also use for science experiments, technology development, and also for Mars demonstrations, key Mars demonstrations. Gateway will allow us to spend more time in the lunar environment, so it gives us a longer stay capability. We'll be adding over the years additional surface elements, rovers. Rovers are extremely important because they give the crew mobility. We'll be able to travel tens of kilometers to explore. The crew will be able to explore different areas of the moon and a habitat for longer stays. We'll be developing key technologies, demonstrating surface power, in situ resource utilization, and more advanced science taking advantage.
Baby, talk to me, Goose.
Of these infrastructures.
That's going to be sick.
All of these things are important for our goals, to develop this deep space economy, which is important to us, enhancing and maintaining our national leadership in space, and to help us on our long-term goal, sending humans to Mars. So with that introduction, now it's time to learn more about these 13 regions and where we may land, and to go more into that, it's really my pleasure to introduce a person I've worked with closely on this topic for a little over 2 years.
Very nice.
It's the agency's Chief Exploration Scientist, Jake Bleacher. Jake.
What do you got for me, Jake?
Hey, thank you so much, Mark. And as Mark said, it really is a pleasure working with everybody on this. And I've said several times this week, I feel like we're on a roller coaster.
RJ, they said lunar Starship test would be between Artemis 2 and 3.
I mean, buckle up, everyone. We're going for a ride to the moon here. In 2009, NASA launched the Lunar Reconnaissance Orbiter, which we lovingly call LRO. Our friend LRO, it's important to remember, was a joint endeavor between science and human exploration. In addition to all the science, it was in part
called
to collect
Elvis?
the data needed to help
Tell 'em
us
we're going back to
decide
the moon.
where to land
Look
the
out, man.
spacecraft. Well, LRO did its
We're
job
gonna
well,
win this race.
as have all of our human
Lemonade.
robotic predecessors whose shoulders we now stand upon as we gaze into this new era of space exploration. NASA was given the challenge to land in the south polar region of the moon in order to take advantage of unique environmental conditions. Conditions
Water.
that provide greater than average amounts of sunlight. Conditions that provide us with access to volatiles. Volatiles that will unveil new secrets about our solar system, while potentially also yielding valuable resources that can help support the emplacement of future infrastructure like Mark talked about. This course was set for us in order to begin building a blueprint for exploring the solar system through collaboration with partners in industry, academia, and our international partners.
Macadamia nuts.
NASA will not do this alone. NASA will lay the groundwork for humankind to explore and learn about our place in the universe.
How's that, fellas?
But what is so exciting about the south pole of the moon?
Water.
Well, to explain this, we kind of need to take a mental walk from the equatorial region of the moon to the poles. I think most space
Let's walk
enthusiasts
then.
are familiar with Apollo views of the moon. Astronauts, rovers, exploring fantastic features of the moon. Features that are all bathed in sunlight as far as the eye can see. However, at the poles, the lunar seasons, coupled with an extremely low axial tilt for the moon of about 1 to 1.5 degrees, they yield a much different scene. At the equator, a lunar day spans roughly 14 Earth days of continuous sunlight,
Yep.
followed by about 14 Earth days of continuous darkness. That's in the order of 330, 340 hours of sunlight and darkness, repeated over and over.
3.33.
Nearly every place near the equator has a 50-50 split of light and darkness. During the daytime at the equator, you're completely in sunlight. You move a mile over there, or 5 miles back here, you remain in sunlight. At the poles, the lighting is different.
Listen.
The ratio, light to darkness, can vary significantly. It ranges from permanent darkness, locations that never see sunlight, to nearly complete exposure to the sun through a lunar year. What makes this situation even more complicated is that the ratio of light to darkness at any location, well, it varies over short distances, and as little as a few miles, sometimes even short distances like a football field.
That's really important,
That ratio
dudes.
can drastically different. While these sunlight conditions might sound complicated, thanks to LRO and our other spacecraft at the moon, these conditions are predictable. Although some locations might be dark most of the year, we will know when they are going to be in the light. While it might seem complicated, it's these very conditions that provide us with the rationale for going to the South Pole. Finding locations with greater than average amounts of light enable us to design systems that take advantage of light for energy and thermal control. Similarly, locations in permanent shadow, which are unique to the poles, provide opportunities for access to water and other volatiles that are trapped there.
Right
but
there.
They don't become stripped away by the solar wind. Although these conditions can be modeled and predicted, I think you can imagine many different technical considerations must be made in order to land here.
3 is going to land.
In 2020, NASA organized a multi-directorate group to coordinate among our different technical teams that were modeling potential lunar landing conditions. This team is called the Cross-Artemis Site Selection and Analysis Team, or CASA.
No, the whole
CASA is our
mission,
home
Kyrie.
for coordination between multiple directorates and the technical experts who have been assessing possible landing locations for Artemis III.
Correct, Kev.
CASA includes representatives from the Exploration Systems Development Mission Directorate, Space Operations Mission Directorate, the Artemis Campaign Division, the Science Mission Directorate, and Space Technology Mission Directorate. Including both myself and Sarah Noble, who will speak next. We also have Tamara George from the Artemis Campaign Division, Brad Bailey from Science, and Jonathan Bowie from the Space Technology Mission Directorate. CASA, working closely with our technical experts across the directorate, identified the technical considerations for evaluating landing locations. In addition to exposure to sunlight throughout the mission duration and access to volatiles, we additionally considered low-slope terrain, Earth visibility for communications, landing accuracy,
I'm sending my
resolution
contractor a
of
picture of the
available
landing
surface
sites
data,
because he's curious about it. I'm
combined
not even
vehicle
kidding.
mission capabilities of the Space Launch System, the Orion, and the Starship Human Landing System. all of this being considered within 6 degrees of the lunar south pole. Because there are no locations of permanent sunlight, none of these regions are accessible continuously at every launch opportunity. So we can't go to one spot regardless of when our launch window comes up. I like to think of the South Polar region as a target-rich environment. As such, throughout this process, we've identified 13 regions that are accessible for Artemis III at various times throughout a lunar year. And we'll continue to work in partnership with SpaceX to further evaluate these regions. We define a region as a surface location about 10 by 10 miles, 15 by 15 kilometers. And each one of these includes several landing sites, which are on the order of basically the landing ellipse of the vehicle about 100 meters across. So a region might be considered as a series of parking lots, while a site is a single parking spot for a lander. As Catherine noted at the beginning of the teleconference, NASA released a video and an image that highlight these 13 regions just over an hour ago. Please refer to these products to see the exact locations of those regions, and I will reference them now from left to right. NASA is excited to announce the following 13 regions of potential locations for the landing of Artemis III. The rim of Amundsen Crater, the northeastern rim of Nobile Crater, called Nobile 2 on the image, the western rim of Nobile Crater, called Nobile 1, the Leibniz Beta Plateau, the rim of Falcini Crater, an elevated region between the Shackleton and Slater craters, Malapert Massif. We have 2 regions along a high-standing ridge that connects the Shackleton and Degerlache craters, the rim of Hallworth Crater, 2 locations along the rim of the Degerlache crater, and a massif between Degerlache and Coker craters. All 13 regions are favorable with respect to the landing considerations. Additionally, as the first landing in the South Polar region, Artemis III will provide unique new opportunities for both science and technology activities. We also hope that by sharing these locations publicly, we can begin collaborating broadly on assessments of the value of going to any of these regions for Artemis III. Now, I want to cite a quote here. Knowing that Apollo 17 would be the last Apollo mission to the moon, Apollo 17 astronaut Eugene Cernan reflected on his expectations.
Between 2 and 3, yes.
At that time, he stated, "The theme of our mission is that this isn't the end. We've just begun to crawl with the Apollo program. We're just now hoping that we can begin to walk as we press on into the future." Well, sir, we accept the challenge. Skylab, Shuttle, the International Space Station, they have all taught us how to survive and thrive in low Earth orbit. And we're now ready to take that walk. Discussing the regions where Artemis III mission can land is our exciting first step on that path. Now I'd like to hand the discussion over to Dr. Sarah Noble. Sarah is our Artemis Lunar Science Lead from the Planetary Science Division at NASA headquarters.
Thanks so much, Jake. I'm so happy to join you today to talk about the great science that our astronauts are going to be able to accomplish at the lunar South Pole. You know, Jake and I have looked at each other a number of times over the last couple of months and thought, boy, things really are getting real.
Thank you for
and
the
it's
read.
really exciting to be able to get to this place where we can start talking about this with the community. I want to emphasize, first of all, that this is a new part of the moon. It's a place that we've never explored. It's a long way away from the Apollo sites. You think about Apollo, all 6 Apollo landing sites were in the sort of central part of the near side. And now we're going someplace completely different in ancient geologic terrain. And more than that, Jake talked about how the poles are unique because of the lighting conditions there. And that extreme lighting conditions leads to really extreme temperatures inside some of these craters where the sun has literally not reached for billions of years. And some of the coldest places in the solar system exist there. And those cold chaps are places where we believe that water and other volatiles get trapped. It is so cold there that molecules bouncing around the moon bounce into one of these cold traps and can't get back out again. And so we are very excited, not only for, as Jake talked about, as a resource, but also from a science perspective, to understand what is present in these places. Where did that water come from? How did it get there? Where has it been? What is happening not only on the moon, but across the solar system? How is water moving around?
Birthday lunch plans.
And so we're really excited to figure out what
birthday.
science we're going to do at these 13 regions. We can do exciting science at all of them. We can access these
Happy
ancient
birthday.
terrains. We will be able to access water and other volatiles that we'll be able to collect, seal, and bring home so that we can study them here in our labs on Earth. So I already know that many of our scientists have gotten hold of this press release an hour ago and are poring over it. I've seen some of the comments on Twitter. Everybody already has favorite places. And as they start looking at these sites, they will find many of them are familiar. Many of these are places that the science community has been talking about for years. And as we look towards our next step and start diving down deeper into each of these regions, we're really looking forward to hearing from the science community about all the great science that can be done at each one of these individual locations so that they can help us prioritize. We are already in the works of planning a workshop early next year to really engage the community with the goal, of course, of finding locations that are both safe to land and full of exciting science to explore. We're really excited to start those conversations. We'll be starting them already next week at the annual Lunar Exploration Analysis Group meeting, and I really look forward to hearing from the community. So now I'm going to turn it over to Prasanth Desai from the Space Technology Mission Directorate to talk about technology, infrastructure, and the future.
Good afternoon. This is Prasanth Desai. The Space Technology Mission Directorate enthusiastically is participating in these discussions to understand and ask questions about how the selection of Artemis III landing regions and landing sites down the line may affect later missions. From STMD's perspective, we need to proactively plan and develop technologies and make them flexible enough to function in multiple regions. STMD is already investing in and advancing key technologies relevant to later flights. We use our entire portfolio, including the Lunar Surface Innovation Initiative, to mature infrastructure-related capabilities for a sustainable lunar presence. One key area is power. We're developing technology to improve solar power, like the vertical solar array effort that's ongoing right now, to mature deployable solar array technology alongside participation and partnership with industry for use on the moon. We're also collaborating with the Department of Energy to develop nuclear power technology. And we recently announced 3 awards to 3 companies to develop preliminary designs for fission surface power systems that could be used on the moon. Power is limiting all other activities.
Want to see the landing sites?
This is one thrust for us initially to provide the power that allows all the other systems to operate and work. And so
South Pole.
This is where a lot of our energies are being put into at this point.
Cool, huh?
The Science Mission Directorate's Commercial Lunar Payload Services, CLPS,
pretty sweet.
Initiative is key for getting our technology to the moon to test.
There's water.
We have quite a few
ice in
payloads
there.
manifested
So
on
they're going to try to
upcoming
land on
Eclipse
this
flights.
ridge. And they're
One
going to try
that
to
we're
get the
very
water from the
excited about
craters.
is the in situ resource utilization realm, which is Prime 1, which is a combination drill and mass spectrometer to drill into the lunar regolith
that was
and analyze it for water and other counters. Some examples of the types of questions we ask related to the landing regions are: do the landing regions include multiple sites for both human and robotic landers? What impact could plume surface interactions have? What are the terrain conditions in the landing regions regarding in situ resource utilization opportunities?
Alucard,
and how could the terrain affect solar power production?
Nail it on the first try.
Looks
Get
forward
right in
to
here.
the upcoming discussions with the broader
That's
community.
where I'm at, dude.
Through the Lunar Surface
that damn
Innovation
connecting ridge.
Initiative and Lunar Surface Innovation Consortium, we
Jawohl.
collaborate
I'm with
with
you,
industry,
man. Let's do it.
academia,
Schnam.
across government to develop the technologies needed to explore the moon and with both human and robotic explorers. The Lunar Surface Innovation Consortium is operated by the Johns Hopkins APL facility, which is also hosting next week's league meeting. With the eventual site selection, we aim to learn everything we can about the terrain, lighting conditions, communications, and more to further improve the development and demonstration of technologies such as in situ resource utilization, solar and nuclear surface power, excavation and construction, as well as all the other systems that we will need for sustainable presence on the moon as we go forward.
Oh, this is gonna
With that,
freaking.
I will pass the to the next speaker.
Thank you, Prasanth. We will now open the line for questions from the media.
Oh boy,
For
my
reporters
favorite
on the
part,
line, you can
dudes.
press *1 to get into the
Let's
question
go.
queue to ask your question. Please remember to state your name and affiliation and address the speaker you'd like to answer your question. Again, we ask that you please stick to one question at a time. You may enter the question queue again and ask an additional question if we have time. You can also press *2 to be removed from the queue if you no longer wish to ask your question.
Artemis missions, Clayton.
Discovery.
That's what
So
I want to
first
go back
we'll
to.
start with Marcia Dunn from the Associated Press.
Dizor.
Oh, hi. Yes, I think for Mark, just Artemis III general questions. What happens to Starship after it brings back the crew and
I had
is
that
back
question
in
as
orbit
well.
and has dropped the crew off in Orion? Does it go back to the fuel depot? Does it come back to Earth? I'm just curious what happens to it, and will it be taking logistical gear down to leave behind on the lunar surface?
Oh, that's a
for
great
future crews?
question.
Thanks.
Yeah, two great questions. I'm going to address the latter half first because I know more about it. The Starship, if you've seen it before, is a big spacecraft and it has a lot of capability.
Hey, Dander.
So there are plans for when the Starship lands, it will include both utilization hardware for us, science experiments, technology experiments, and also SpaceX may include their own cargo they bring from the Earth. They could, like, for example, other commercial instruments down to the moon, and they would coordinate all that with us. I have to be honest, I am not up to date because I know the HLS program has been working with SpaceX on the plan. Eventually, we'd like a reusable Starship. I don't know exactly where we are for the Starship disposition after Artemis III.
He said the word.
That answer, though. If Catherine would help me, we will get that. I know there are people working that, but thank you.
Thanks, Mark. Marcia will follow up with you offline about that one. Our next question is from Jeff Faust of Space News.
Jeff.
Yeah, good afternoon. Question for Mark or whoever else. I'm just curious, how close to the Artemis III launch will you actually select the actual landing site for the mission, and will that landing site vary on a month-by-month or season-by-season basis based on lighting conditions? Will you basically have sort of like a rotating set of potential landing sites you would choose from based on when Artemis III actually launches? Thanks.
Yeah, great question, Jeff. Our plan right now is we would like to firm up our landing sites, and I'm going to say plural, about 18 months prior to the launch. Okay. And the reason that is because we will spend time developing more detailed, once we know the regions, the sites we want to go to, we will spend time writing procedures, developing flight plans, training the crew, and that takes some amount of time. So end of our target is end of 2025, late 2025 for this mission. Sometime in 2024, we'll narrow down the list. We will have to, just because of what you heard about today, because of things like lighting, the seasonal variations, where these landing sites are, how they move in relation to the Earth, the look to the Earth, if you will, all of that changes. So we will have to have, likely even for a given launch day, perhaps one or two sites, but we will have a collection of sites that we can use along a launch period, a series of months, just like, for example, Artemis I, they have other day opportunities. We'll be looking at that too. We will be more than one. Exactly how many, we don't know yet. We have a lot to learn in between now and then. So we have a lot of mission planning work, a lot of coordination across our groups.
Thank you, Mark. Our next question is from Kenneth Chang of New York Times.
Hi, thank you. I was wondering what are the operational constraints of where Starship can land? The crater density, the angle of the slope, crater, and so on.
Yeah, that's a great question too. That is the latest entry in terms of our mission planning constraints. We on the NASA side have been at this landing site planning since the Space Council announced several years ago we're going to be going to the South Pole. It was just recently. When I say recently, it's been several months. Have brought SpaceX into this, and we are learning about their vehicles' operational constraints. In our early studies, we used government estimates, and now we're pulling SpaceX in as well. And as they're learning about their vehicle, they're early in their design. What I'd really rather do on this one, Ken, is this one I'm going to defer. I'd suggest if we want to know more at the moment, we pull in SpaceX or set up a discussion between SpaceX and you on this. It's still early for us to be talking exactly about their vehicle constraints.
Yeah.
Thanks, Mark. Our next question is from Irene Klotz of Aviation Week.
Yeah, the South Pole is pretty tumultuous terrain.
On a
It's pretty
related
rough.
note, probably for Jake, what determined the 100-meter landing ellipse?
So those are values that we actually had in our requirement set.
It's
and
lighting
one,
conditions, temperature,
knowing
water.
how complicated that the South Polar region is,
Lighting conditions
from
is
the
the big
perspective of light and the terrain.
See?
We want to be able to get close enough to the locations where we want to do the work. So working with our science community, working with our technology community, we want to be able to land close enough, even on this first mission, that we can get out
the woman in the red
and
dress?
be right at the
Look
places
again.
that we want to work.
She is now the
So
moon.
we worked through that, and that was what we put into our requirement set for the HLS, prior to SpaceX being selected. So that's what we're trying to do, is make sure that we're close enough
that's
to
okay.
the target locations we want to be able to get to, and then we can better plan a mission from that perspective.
Yes.
Thank you. Our next question is from Steve Gorman of Reuters.
Yeah, hi. Thank you for doing this. I had a question. How much, if any, manual control over the landing will the crew have for Artemis III and for subsequent missions?
Yeah, another great question. The Starship will have manual control, so the crew will have some capability. What we want to do is,
that's sick.
Any specific questions about Starship capabilities today, since we didn't include SpaceX, we want to reach out to SpaceX. So we're going to get our NASA comm folks to help you do that today.
Elon should have been here.
Thanks, Mark. Let's see. Our next question is from Megan Bartles of Space.com.
Hi, thanks so much for taking my question, which I think is for Jake, but if others want to chime in, that's great. Now that you have candidate regions, will LRO be tasked to investigate those, and what might that work look like?
They investigated them with
good
the LRO
question.
to find these.
So the Lunar Reconnaissance Orbiter is not currently in an orbit that will enable us to image these sites. But part of what went into some of our considerations for sites was the basis of availability of data so that we can meet some of our other considerations. So being able to look at the roughness of the surface, for instance.
Okay.
So the sites that we're talking about are places that the Lunar Reconnaissance Orbiter, based on a heritage of discussions that are documented in the community over many, many years, these are places that we have targeted specifically with LRO already. So we can't target these locations again with the Lunar Reconnaissance Orbiter, but we have targeted them specifically in the past.
Thank you. Our next question is from Michael Greshko of National Geographic.
Hi, thanks for taking my question. I think this one might be for Jake as well, but anybody can chime in. How has the decision to delay the Viper rover to a late 2024 launch affected or changed the plan for evaluating these potential candidate landing sites for, among other things, their volatiles? Thanks.
All right, I'm back.
So I think I'll take that. So I think, Viper is of course a necessary first step towards understanding the resources available. But we do actually have a lot of information about where we think those resources are from our science community, from orbital capabilities like LRO, but also from modeling and within our science community. And so we actually have quite a bit of information.
Here,
of course, we want ground truth from Viper, and that's really going to help us. But in terms of being able to select landing sites, we don't need Viper's data.
Thank you. Our next question is from Marvin Marshall of Nighttime News Space Report.
Hi, my name is Marvin Marshall from the Nighttime New Space Report on Twitch here. This is for Jacob or anyone who wants to answer here. It's from one of my viewers named Joe. Joe wants to know, are you guys planning on visiting any of the old Apollo sites on a detour to learn about the wear and tear on instruments and equipment that may have been up there for, over 50 years now, exposed to the lunar space there? Thank you.
Yeah, this is Jake. I'll take a first cut at that. That is a very interesting topic, and we have discussed the value of doing that. And as your viewer has noted, there is value in understanding what has happened to the hardware that has been on the lunar surface for that long. But we also are very interested in protecting the Apollo sites. They're referred to as heritage sites on the lunar surface, and we actually have some public documentation about that. So they're somewhat protected regions, although we do have the potential to use them if there's something that we need to learn. But we can also begin to learn about some of those processes by having a regular cadence of landings in the South Polar region. We can leave witness plates, for instance, to understand the impact on the surface. Especially if we get to a point where we're landing, at or near the same location, we can revisit those. We don't rule out the option of potentially going elsewhere, but right now our focus is at the South Polar region for Artemis III, and these 13 regions are the places that we are now trying to assess further, and as Mark indicated earlier, try to get to a shorter list, as short as we can.
Thank you. Our next question is from Thomas Schumann of Radio Fall, Denmark.
Yeah, hello, and thank you for taking my question. I don't quite know who would be able to answer this, but I'm wondering what the astronauts would need to train in to explore the permanently shattered craters. What are some of the unique things they would need to train for?
Yeah, this is Jake again. I can start that answer, and maybe others have some additional input. We have to learn how to operate in some of these locations that are unique, of which, as you know, the permanently shadowed locations, they are certainly a unique aspect to the polar region. One of the things that Sarah noted this already, and I did earlier as well,
I don't even know.
Permanently shadowed locations may contain volatiles, frozen volatiles, in fact, that maybe we can go sample and begin to learn about. So we have a lot of questions about these permanently shadowed locations. What is the makeup? What is the relationship of volatiles and the regolith? What is the surface roughness inside these craters? Can we get down to the volatiles? Is there enough volatile there that we can actually sample it and or potentially extract larger volumes of it in the future? These are all questions we have. So the skill sets needed to do that will most likely fundamentally be, from a science perspective, understanding the geoscience aspects to it. So kind of your traditional field science skills we'll need to use there. But we're also going to have to learn how to operate in that total darkness on the lunar surface. So we do have questions about how much reflected light might go into these locations, and how do we actually navigate and work inside there, and actually how cold do they get at the scale of a person walking around. These are all questions we have. So permanently shadowed locations, regions, will certainly be a target of interest for us, trying to just understand them, understand what they hold for us from a science perspective and from a resource perspective, and in general, just starting to learn how to operate in there. So that's kind of what we're going to have to bring forward.
Yeah, and I can add to that, Jake, that it's not just operating in these permanently shadowed regions, but understanding how to do field geology in these extreme lighting conditions, even outside of these permanently shadowed craters, is going to be a challenge. And so we're actually practicing. We're going out at night and doing analog activities where we bring our own sun and we test out the lights on the suits and make sure that our astronauts can actually see the geology that they're trying to study. And so we are actually already in practicing that and trying to learn how to do that and to optimize the situation for the astronauts when they get there.
Thank you. Our next question is from Manuel Mendanti from Debate.
Hi, good afternoon. How are you? Sorry, I apologize if you mentioned this during the presentation. I wonder that given that you took the decision along with SpaceX of these 13 places, I wonder if is it safe to assume that the first HLS demo flight will land in one of these places?
The uncrewed demo flight. Yeah, great question. We have a different arrangement for the uncrewed demo flight. SpaceX will actually lead the selection of where they land on the uncrewed mission. We have asked them, they will land at a similar location between 84 and 90 degrees, so again, within 6 degrees of the South Pole, but they will lead the selection. They may or may not use the same set of constraints, and they will make the primary selection, and they will coordinate a course for us, so we may iterate on it, but that's their responsibility. It will likely not be one of these 13 sites, but in the same region. And they're not required to use one of these 13 sites.
That's interesting, dude.
Thank you.
It's not going to be one of those sites, but it'll be in the region.
Enright of Irish Television.
Huh. Oh, Leo. This guy's the best. Leo. Guess not.
Leo, your line is open. Can you hear us? All right, Leo, we cannot hear you, so if you are having issues with your audio, you can rejoin the queue. We'll go now to another question from Marcia Dunn of the Associated Press.
Yes, probably for Mark. I know you mentioned the first woman is going to be on this crew, but we also keep hearing about the first person of color. Is that a requirement for the first landing crew? Is it a desire, or is that TBT?
18 months.
Yeah, thank you, Marcia. Thanks. I know a lot of people talk about both those. So we know on the first mission we are going to land a woman, and whether or not that woman will be a person of color or either of the two crew members will be a person of color, that's not a mandatory requirement for the first mission. Could happen. It could be one of the subsequent missions.
Thank you, Mark. We'll take another question from Steve Gorman of Reuters.
Yeah, hi. I wanted to know, are all these 13 regions considered kind of like equal contenders, or are there one or several of them that are kind of maybe are more promising to you even at this point? And I wonder if you could also go through again some of the craters that they surround. You kind of rattled off names of craters early on before I was trying to get this picture up. But
yeah, so I could go through the list again. So let me go through the list first, and then we can get to the first part of your question. Again, for everybody, you can also refer to the image that we have released about an hour before the beginning of this teleconference. But the 13 regions that we're looking at are the rim of Amundsen Crater, the north.
Wait a minute. Did this guy just ask to have NASA recap what they already said? He just asked NASA to repeat what they. All right, I just want to make sure.
The Leibniz Beta Plateau, the rim of Faustini Crater. There's an elevated region between the Shackleton Crater and the Slater Crater. The Malapert Massif. There are 2 locations along a high-standing ridge, and that ridge connects the Shackleton and the Dagerlosh craters. There's a location on the rim of Hallworth Crater. There are 2 locations along the rim of Dagerlosh Crater itself, and there's a massif between the Dagerlosh Crater and the Coker Craters. Now, as I mentioned in the introduction, these are 13 regions that are favorable from our perspective with respect to the landing considerations that we talked about. So these are places that we can get to. So those are kind of what we need to learn about to see where we can go. And so now, again, one of the reasons that we're trying to engage the community now and announce these regions is so we can start a dialogue with the community, as Sarah was talking about. If we get to the point where we know we could go to 2 places at the same opportunity, then maybe we can weigh in the value between those 2 locations. But that's part of the work that we have to do going forward, in addition to working with SpaceX to further evaluate these 13 regions.
Thank you. We're going to try to go back to Leo Emright of Irish Television.
Thanks. I hope you're hearing me now.
Yes.
We can hear you, Leo.
Sorry about that. Yeah, I'm still a little bit, I'm trying to get my head around these moving opportunities, because if you spool, I mean, the image that shows us the 13 candidate landing regions is one instant in a 2-week cycle. And if you spool around with that video, you know, only 2 of these sites are visible at any time. They all, you know, they disappear into darkness constantly. So you're talking here about target regions, each one of which only has, it would seem, you know, 4 or 5 days at most where they're fully lit. I mean, you're really trying to thread a needle here, and I'm trying to understand how you do that and keep an astronaut crew safe.
That's a good question from Leo.
So this is Jake. I can start to answer that question. You are characterizing exactly the challenge that we're dealing with right now. And
see, Leo knows what's
you know,
good,
as I
guys.
mentioned in my opening, the Apollo missions took full advantage of the lighting conditions near the equator, knowing that they would have the equivalent of 14 continuous Earth days of light once per month. So they could land in those locations and know that they would have a stretch of 9-10 days of light. But you touched on exactly the difference with the South Polar region. Any of these locations is not in light all the time, neither were the equatorial regions. So we have to model and understand exactly when they do enter into light and for how long. And so one of the conditions we're looking at is that it would need to be in light for Artemis III throughout the duration of the mission. As Mark talked about, it's between 6 and 7 day long mission. So we need that stretch of sunlight, but that's really all we need. So it could be in darkness much of the rest of the time, but if it comes into light for that period of time at the right launch opportunity, we could go there. That's why we're looking at a number of sites, not narrowed down to a specific single one at this point. We have 13 regions, each of which include multiple sites. And as you said, we're trying to look at how we thread that needle. And then, as Mark said, how can we try to reduce that number from 13 down to a smaller number by better understanding with our modeling and also working with SpaceX to bring them into that conversation as well.
Thank you. We'll now take a question from Marcia Smith of Space Policy Online.
Thanks so much. And I want to follow up on that a bit. I'm wondering what the contingency plans are in case something goes awry. So if you have a 6 or 7 day mission and you choose a window when the landing site only has 6 to 7 days of daylight and you can't get off for some reason, maybe you need an extra day to fix something. I mean, are you factoring in any margins in this just in case the liftoff from the surface doesn't go as planned? And just more generally speaking, what are the contingency plans? How long could they stay on the surface if they needed to?
Oh, yes, Marcia. You know, NASA, we look extensively. And by the way, this is Mark, by the way. Marcia, we look at all sorts of contingencies ranging from, you know, when we're sitting on the ground, SLS Orion is sitting on the Earth, and we miss a launch window and have to go to the next one, so we're looking at that. That's why we have multiple sites, multiple regions. And then once we are on the surface of the moon, we're looking at contingencies. First of all, what if we have to leave the surface of the moon before the optimal point to leave, which is 6.5 days? So let's say we land on the moon, something goes wrong, we have to leave an hour later. We have a plan for that. If we have to leave a day or 2 or 3 into our stay, we look at that. And then we also are looking at what happens if we miss our 6.5 day and have to spend another 6.5 days. So all of those are part of our
contingency planning process.
Thank you, Mark. Our next question is from Zach Aubert of Launchpad News.
Yes, Zach Aubert with TLP Network and Launchpad News. Thank you so much for doing this. Somewhat of a different question. We know that China and Russia are both also looking towards the South Pole with planned rovers and different types of probes and stuff in the coming years, kind of on a similar timeline. I guess what type of considerations are looking at where they're going versus where NASA is planning on going, and if there's any cooperation or difference, and is announcing these sites maybe something kind of saying like this is where we're going and hoping they kind of stay away? Obviously, space is better together, but just curious your thoughts there. Thank you.
Yeah, I can take this one. This is Jake. So in general, international participation is a part of Artemis, and in fact, we have the Artemis Accords, which a number of nations have already signed. And we are looking at working in a collaborative manner. And a number of our international partners are, in fact, having conversations with us about their vision for what the Artemis architecture would look like, what contributions they could make. Additionally, we've held a number of workshops. Sarah Noble from SMD, as well as many other folks from SMD, the Science Mission Directorate, have held a number of workshops that have asked the community about places we might want to go, what types of activities we might want to be doing, and international partners have taken place there as well. So we do have a fairly good perception of what many of our international partners are thinking. But, you know, the point of the presentation here today was to, you know, explain what some of the complications are for the South Polar region that we have to anticipate. And right now, as you can see, we have 13 regions, and, you know, some of the questions ahead about, well, you know, how hard is it to go to some of these? And it's not that it's any harder than going and landing elsewhere on the moon, but we do have to take into account some of these environmental conditions, which do in some ways constrain when we can land in certain places. So right now we're carrying a fairly large list. We do know that other nations are considering where they might want to go, and you know, they're working through these complications the same as we are. And you know, if they can go and land, we'll be watching where they go. But we've got these 13 that we're working on now with SpaceX. We're trying to evaluate them, get a better understanding for when we can get to which ones, and then also, again, by talking today about this, encouraging that we can work with the science community, including partners from around the globe, to talk about what they think is the value of going.
I could ask questions if I wanted to, Popsicle.
So,
sure.
you know, at this point,
I just choose not to.
We're working hard as a community, trying to just narrow our list down and get to where we can. But as I also noted, each one of these regions has multiple sites within it that could be considered. So I'm not too worried about overlap. The moon's a big place, and we're going there to learn and study, as is everyone. And so we're just going to keep our mind focused on the task ahead of us, continue to evaluate these 13 regions, and work with the community to understand better from their perspective what the value of some of these places might be.
Thank you. We have time for one more question. We'll go to Jeff Faust again from Space News.
Thanks. Couple of quick follow-ups. One, you've mentioned that these landing regions have multiple landing sites. On average, how many landing sites are there in a given region? And then second, are you counting on data from any future missions to support the site selection process? I assume you'll take in the data that comes in from any of these missions as they develop, but is the site selection process dependent on getting data from future orbiter missions or CLIPS missions or the like? Thanks.
That's a great question. Jeff's the friggin' man. What a great reporter.
Yeah,
He's one of the best in the business.
This is Jake
man.
again. Thanks, Jeff. Good question.
See?
So, you know, each one of these regions has a different number of potential sites there, you know, and it's all really comes down to those questions or those conditions that we talked about.
Shackleton's
but, you know,
a big crater.
10 in each one of these, and in many of them there are more than that. Again, so we're just trying to.
Each one of these craters, dude, is about or not craters. Each one of these regions is about 10 miles wide.
That's for data that we need. We don't need additional data in order to land this Artemis III mission. The Lunar Reconnaissance Orbiter did a great job, as well as the orbiters ahead of it. There will be activities such as Viper. Viper was brought up already. That will help us understand what those environmental conditions are like. Anytime we would go to the polar region, it will help us constrain our models on the lighting there. So any data is helpful, and we're happy to have it, but we don't require additional data in order to complete an Artemis III landing at these 13 regions at this time.
Thank you, and thank you all to our speakers and to the reporters on the line. We'll now go to Mark Kiersich for a few closing remarks.
I have the microphone.
Thank you, Catherine. And thanks to everybody who came to listen today. You can tell Jake, Sarah, Prasan, and I are all extremely excited about it. There's been a lot of work to date. We have a lot of work to go. We're going to be working together to find the best site that works for all of us. And you heard Sarah describe today how we are looking for external inputs. When we bring humans back to the moon,
see what
we want it
said,
to reflect the inputs and thoughts from the best and the brightest and the people who are passionate about this. So we are looking forward to the conferences that we have upcoming to help get other inputs to think about things we haven't thought about yet. And with that, you've heard about us thinking about Artemis 3. We want to go back. I'm going to start slowing down a bit and putting my attention towards Artemis 1. I'm heading to the Cape next Wednesday, and we're really looking forward to the kickoff of this series of missions a week from Monday.
GM's making a rover for him, Hammers.
Launch of SLS.
It's very rough right now, but yeah, GM's going to make one, so if you're a Chevy guy.
And appreciate it.
Thank you again for joining us today. You can listen to a replay of this recording on NASA's YouTube. Be sure to read our news release on the candidate landing regions for Artemis 3, available on nasa.gov, as well as follow along with updates on the upcoming Artemis 1 mission by following our Artemis blog at blogs.nasa.gov/Artemis. And if there are any additional questions, we couldn't get to all of the questions in the queue today, you can email the public affairs contacts on that news release, and we'll be happy to get you additional information. Thank you all, and have a great afternoon.
All right. So we got 13 landing regions. So all right, if the NASA stuff is kind of hard to listen to at times, like I throw a lot of big words in there. All right, so these are candidate landing regions, guys. So these are the regions that they have selected for potential crew landings. Keep in mind, these are sites that constitute what they, with the information given right now, safe enough stuff to conduct a 6 to 7 day duration mission. All right, what does that mean? So, okay, if you notice, if you look at every single one of these landing sites, they're all on ridges. Every single one of them is on like a rim of a crater or a ridge. You have a rim right there, you have another rim right there, rim. You have a plateau that's right next to a rim. You have the Malpert Massif right there. Big up to the Malpert Massif. Booyakasha. Anyway, sorry, I won't do that again. So they're all on ridges, they're all on rims. Why? Why is that? Lighting conditions. When you're at the pole of the moon has a very, very slight axial tilt, and it is tidally locked, but every 16 days is one day-night cycle on the moon, because the moon is permanently, one side is facing towards Earth. That's the dark side of the moon. Sorry. Anyway, so they're trying to pick tall regions that are potentially near regions that could have ice. The bottom of like the Shackleton crater right there, that's the one right in the center, right by the South Pole. The bottom of the Shackleton crater, it's like, I don't know, 2.5 miles deep. There's ice down there. They know there's ice down there. So they want to try and land next to it where there's some ice, because they want to use the ice for prospecting. So yeah, that's what these sites are. They're in a place that's going to be more or less in constant daylight, because when it gets dark on the moon, it gets dark. There's no retained heat on the moon, and if it gets dark, it gets really dark and it gets really freaking cold, really, really fast. So yeah, they really have to. They're really trying to find sites that are capable to have good enough daylight for a 6 to 7 day mission with Starship. Keep in mind that these aren't necessarily the landing sites for uncrewed Starship for the HLS Demonstration 1 mission, which would be between Artemis 2 and 3. Yeah, I mean, you got to take into account surface features. If I had to pick just by a straight shot looking at these guys, I like the connecting ridge, but I think Faustini Rim A is probably a really good spot. Because look, it's relatively flat right there. It is on a ridge and a plateau, and it's next to the Faustini. I think that's the Faustini crater. I think. And it's a relatively short, not steep slope to get into that crater. That's where I would go. If I'm playing Kerbal and I'm landing Jeb on the moon here, probably killing him because it's me. I would pick one of these regions right here. The connecting ridge would be the best scientific region, but that's a tough landing. This is a relatively flat spot. I would go for that one. Dart sends its regards. Connecting ridge would be the money shot, man. That would be the one, because there's water ice in the Shackleton crater. Because think about it. Because you're on the South Pole, the sun is never going to shine into those craters. So there's leftover water ice up there that hasn't been melted. There's water ice left over from something. Could be from these impacts. Who knows? Connecting extension. Yeah, that's not too bad. That looks pretty... It's not too bad. But yeah, keep in mind, these sites, they're going to hone it in over time. So think about it like March Madness. You have all these in a bracket, and you'll slowly refine it till you get to the championship. That's basically what's going on. But if the world is hollow, or we get to discover the entrance to the inside, it's not. Well, it is kind of hollow. There's just liquid down there. It's just liquid metal, iron, and hotness. Anyway, so fellas, I'm actually going to take a break here real quick. I do have people working on the office right now, but I'll be back in a moment here for the for Starlink coverage. We should have a Starlink launch very soon. So give me like 10 minutes, and then I'll be back for the launch, okay? Try arching your shoulders. Oh, he's trying. Anyway, I'll be back in a moment.
Discovery, go at throttle up. Discovery, go at throttle up.
Okay, we are back here. All right. Starlink mission is up here. Okay, cool. Back in time. All right, let's do this. Let's get that off the screen. Go over here.
To support liftoff just a few minutes from now. And in preparation for liftoff, actually
So
just
Starlink
before we went live, the transporter erector had retracted away from the vehicle, and we've opened the clamp arms around the second stage.
Stage 1 lock flow complete.
There's a 50% POV on this sucker. All right, let's
So
see.
with about T-minus 3 minutes to go, the first stage has completely loaded.
Looks pretty clear out there.
That's rocket propellant 1 fuel and liquid oxygen on the first stage, and we're awaiting completion of a similar call out for LOX load complete.
The fairings
on the
are a little
second
dirty
stage at
hypersonic because they've
about
been used a
T-minus
lot.
2 minutes.
Discovery, go at throttle up.
Hey, Allie, 55-month resub. Sorry I haven't been here. Real life got in the way. I know what you mean. It's all good, man. Yeah, Baranok, it's got a real weathered look to it, huh? Real rustic look. You seem to be 30 seconds behind. Oh. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. T-minus 2 minutes.
Stage 2 lock flow complete.
Stage 2 LOX load is complete.
With that, we have completely loaded propellants on both the first and second stages. That's fuel and liquid oxygen. About 1 million pounds of propellant across both vehicles. And today's launch marks SpaceX's 93rd from Space Launch Complex 40. Looks like a beautiful day for the ground.
What am I looking at? When is this happening in the launch? Now. You're looking at now, chat.
You can see the soot on the side of this.
Everything that's happening now is happening now.
We'll be attempting to recover it in the Atlantic Ocean on a drone ship named a shortfall of gravitas.
What are you preparing? You're always preparing. Just go. Just go. Chat, you better buckle up. Yeah, buckle this. You lost the bleeps, the sweeps, and the creeps.
SpaceX, Falcon 9, Starlink, go for launch.
Launch director is reporting go for launch. Looks like a nice clear day. Are you sure there's
30 seconds.
Are you sure there's 50 POV on this launch? It's got to be wind. 20 seconds.
T-minus 15.
Discovery, go at throttle
10
up.
seconds. Avatalk's in.
T-minus 5, 4, 3,
Savage.
2,
Shot.
1. Lift off.
All right, she's flying. There we go. Hey, Shot. Thanks for the words, man. Right on.
She's down right.
Shot, I'm not at C5 cargo bay, but we're close. You know what I'm saying? I'm not. My garage could fit inside of it. Actually, you know, it's pretty close. Anyway, she's flying. "30 seconds into the flight. Stand by for the call for power and telemetry."
Discovery, go at throttle
There's
up.
the throttle up call from Podway. Blast off.
Power and telemetry nominal.
Oh, look at you remember this C5 shit. How'd I remember everything, man? Steel trap, man. There's the call. Oh, look. Oh! Oh! That doesn't suck. That was
You just
cool.
saw their Falcon 9 transitioning to faster than the speed of sound.
Oh, what a great shot. Stand by for maximum dynamic pressure. It's over 9,000 Q. It's
And
almost
with that,
9,002
we are through
Qs.
the point of maximum aerodynamic pressure that the vehicle is going to feel during the ascent phase.
Oh, that's pretty.
And back chill.
Oh. MVAC is chilling.
Now we're coming up on
Note
3
that it's
events. First
pointing
of those will be
radial
main
out again
engine
on the
cutoff,
ascent.
followed by
Falcon
stage
9's kind of
separation,
pitching
and then
up a
second
little
engine
bit.
start number 1.
Look
Keep an
at
eye out
how
for those
much that
happening
rocket is
back-to-back.
pitched
We
up.
just heard that call out for
Whoa.
beginning chill of the Merlin vacuum engine on
You
the
guys,
second
you'll
stage.
see it. When they get up to the main, like almost the main engine cutoff, Falcon will pitch down and it'll align with prograde for staging. Like, look at it. You can't even see it. You can't even see the dang thing. The rocket, Falcon 9's flying like this.
Discovery, go at throttle up.
Watch, it'll tilt back down here in a moment, and you'll see the nose cone. Yep, see, there it is. Tilted back down. You can barely see it up there, but you can see it. Stand by from Eco. That's main engine cutoff right there.
Eco.
There's the call. Stage separation.
Separation confirmed.
Oh, very nice. Why is it flying that way?
MVAC ignition.
They're trying to boost it higher into space.
Fairing separation confirmed.
The fairing sep. Oh,
So
nice. This
Eco,
never gets
stage
old,
separation,
man.
and then Merlin vacuum engine
This is
start,
great.
followed by fairing separation. These fairings are marking their 6th
Golf clap.
flight and
Got a
5th
nice golf
flight,
clap.
respectively, and we'll be attempting to recover them on our recovery vessels for use on a future mission. Today's mission marks the 56th overall mission to use reflown fairings.
How did we get here? 6th flight of those fairings backing up. Nice. Looks right to me, old force. Yeah, everything's looking good here. So now we're going to coast for a second.
So far, burn performance looking normal right down the middle on both the vehicles.
Yeah, hypersonic.
Left-hand side of your screen, you can see our first stage.
Acquisition signal, Bermuda.
I'm looking
It's
for an apocalypse.
transitioning,
It should
getting
be like
the engines and the heat
132,
shield pointed down
133.
for re-entry. The right-hand side of your screen is our second stage, a view of the Merlin vacuum engine with a beautiful view of planet Earth in the background.
All right, Baz. I'm going to make myself a little bit smaller, okay? I wish I was a little bit smaller. Wait, that's not the lyrics. Yeah. 135. Yeah, see from that pitch up, man, that thing went really
These
high.
mission marks are 175th overall launch.
Right, Krasno?
The
Hell yeah,
booster
it's a
on the left-hand
As
side
the
of your
kids would
screen
say.
has previously supported 8 missions, 2 crewed missions, the Axiom
Beautiful
1 and
flat
Inspiration
disc.
4 missions, NALSAT 301, 2 GPS 3 space vehicle missions, both space vehicles 4 and 5,
135,
as well
yeah,
as 3
it
previous
pitched.
Starlink missions.
She pitched up pretty hard there. That's higher than normal. They usually go for like
Both
133,
vehicles
132.
trajectories.
Coming down. Hey, mute hand, 64 months. Thank you. You can put yourself on Falcon 9. No, I'd have to put the couch on Falcon 9, man. There's a shot up the business, or no, not up the business. That would have looked up the business center where the second stage was. That's what that bright shot on the left was. It was on the first stage looking up. Yeah, they optimized the trajectory a little bit, Spoon. Probably so why would they do that? They shoot the satellite up there. Sorry, my keys were falling off the desk. They shoot the.
Now,
they get
the view we have right now is
they're
of
trying
the
to squeeze
Merlin
more
vacuum
performance
on
out of the
second
first stage
which
to
is carrying
prolong
our Starlink
satellite
satellites to orbit.
to
As a
get
reminder,
more
Starlink
life
is
out of
a
the
satellite
satellites
of
because
internet constellation.
Shiva, for a second. They're trying to basically make it so they push. They're pushing the satellites up higher. The higher that Falcon 9 can get those satellites, that means the less time the satellites need to use their engines to get up to their final orbit. So if they're trying to squeeze basically every last bit of performance out of that first stage. That's why it pitches up on ascent, and that's why as we go higher and higher, or as we get into more Starlink launches, we've seen the apogee of that first stage. So the highest point that the first stage goes to, it's getting higher and higher and higher and higher.
Heat shield pointed down. You can also see the grid fins
Nah,
deployed
looks
in
about right to me,
preparation
Orion.
for guiding the vehicle once we get into the thicker parts of the atmosphere. Next major event.
For
or
Starlink
the first
mission
stage
Cyborg,
is
they
our
deploy
entry
that
burn.
quickly. Yes,
It's coming
that's
up
normal.
in about 20 seconds.
Yeah, Smoke, this is live. I missed the Starlink last week, dudes. It's like that Starlink, and there's one other Starlink Falcon 9 that I've missed. Other than that, I've watched every single one of them. I've only missed 2 in the past, like, 10 years. That's pretty good, right? Supersonic retro propulsion! Yes!
So successful startup of 3 of the Merlin
Falcon 9's doing the supersonic retro propulsion entry burn.
Slowing down the vehicle as we start getting into the atmosphere.
And it's the heat shield. The flames from the rocket are the heat shield. That's the best part. It's the most metal thing I've ever heard. Ugh! Wait, I just realized you're at the new house. Congrats again. Hope you're enjoying the new place. Huh. Am I enjoying the new place? Here, real quick. I'm in a freaking cathedral. Look at this.
Stage 2 FTS is saved.
Streaming next to my damn truck. With the grill of another truck behind me. Devious, it ain't bad, that's for sure. We're in a damn cathedral. This is just a temp setup. I got some stuff planned. I got some stuff planned for this whole area. Don't you worry.
Stage 1 transonic. Terminal guidance.
So with that call out, the first stage is transitioning to speeds lower than the speed of sound.
All right, here we go. Stick the landing. EJ religion soon? No.
Coming up, next activity for the first stage is the landing burn.
The real question, Alucard, is who would win in a fight, Lemmy or God? Trick question. Lemmy.
And here's a good shot of the first stage. You can actually see.
Come on, go through the clouds. Here we go. Landing burn started. Come on, punch right through the clouds. Oh, that's gonna make my day. That's so cool. That's awesome. We have second stage engine cut off, and oh, that's kind of quick. Oh, bullseye!
And beautiful shot of
oh, that's nice.
Marks the 130th landing of the Falcon 9 first stage.
That's nice.
Our 57th overall Starlink mission and our 37th launch of the year.
Don't hate that.
And in case you missed it,
don't
there's
hate
a call
that.
out there as well for second engine cutoff on the second stage.
That was quick, dude. That was real close.
And just confirming that we are in the intended orbit.
I know, Ning. I'm right with you. That's never not going to be cool.
And we did get a call out there for good orbit. So with that, the second stage is
Dude, you see how quickly that thing throttled? I'm like, oh my gosh, it's going to crash. And then it was just like, no.
For today.
I'm like, oh.
Thanks a bunch for tuning in.
No, Shiva. I want to see the landing again. Shiva, don't you dare. I want to see that landing.
Stage 1 transonic.
Punch through the clouds. Oh, that's so cool. Dude, it's like this thing is coming in hot, and then it just yeets the engine right at the last second. Yo, that's awesome. What a great landing. That's so freaking cool.
130th landing of the Falcon 9 first stage.
You gotta be kidding me. There was the call for NOI in there, but yeah. Yeah, it had a little bit of a bounce. Right there, they're venting down the tanks from flight pressure. Man. That's pretty cool. Like I said, guys, I've missed 2 Falcon 9 launches in the past 10 years. I always watch it. You know why? That never gets old. I was there when they landed the first stage. It was the first stage, right? Orbcom back in 2015. I have not missed a Falcon. I've missed 2 Falcon launches since Cassiope in 2013 because I always want to watch that because that's really freaking cool. It's still awesome. Even to this day, that blows my mind. That's a 15-story building. The thing is almost as long as a 747. It's freaking huge. They're definitely, yeah, Spoon. They're definitely optimizing Falcon's trajectory. They're definitely doing that. Yeah, Raja, it's pretty quick. But anyway, it's pretty nuts, man. Pretty nuts. Falcon 9 with the second stage and the fairing neuro is as wide as a 747's wingspan. So the first stage probably like the size of a 737. That's still a pretty monumental feat considering it's a VTOL, you know? I mean, and Falcon 9 is VTOL in the truest sense of the term, vertical takeoff and landing. Which is pretty freaking cool. Seeing the rocket come down in person, Aiden, is definitely something everybody should see. It is the weirdest thing you've ever seen. It doesn't look right. It just don't look right. Because, you know, the camera doesn't really convey this, but if you're close and you can see the stage coming in, it just looks strange. It doesn't... Yeah, the first time I saw it happen, I'm like, okay. When will they start? When will they start what, Ram? So I know you've seen this, but I'm more hyped about this than for the Artemis 3 possible landing sites for some reason. Oh, yeah. Yeah, fellas. Okay. So, Thomas, I have contractors here. So, I'm probably going to be back for Space News a little bit late tonight, dudes. Space News is going to be in the twilight, man. Yeah, my contractors just decided to come right when the NASA presser and this all happened, so I gotta go. They're standing there giving me funny faces and making fun of me for a job on the internet. Whatever. Anyway, do you still do NASCAR gaming streams? Sometimes on Fridays, random. Yeah. Go build. Damn right, Shahad. So, yeah, fellas, what I've been working on, here, I'll show you. For the people that don't know, the garage has an office attached to it. There's an office behind it. Let me take a picture. I'm going to do the boomer thing and show you my phone. Hey, thanks for the bits, Dave. So, I've been working on furnishing the office. That office is like right through the wall over there. I've been drywalling it, and now my electrician's here, and we're going to hook up power and everything. And I've been sanding the drywall myself. But I gotta do drop ceilings. We gotta insulate the drop ceiling. I got all the carpet and the baseboards and everything, but I'm just trying to get all that done for next week so I can get off of this casting couch and get back to doing regular streams. Good to see the dust has finally settled. Yeah. So that streaming setup, the idea is with the streaming setup in the office and the garage right here, the idea is that I can go back and forth between like working on a car or building high-powered rockets, back to Kerbal, back to Space News. We can go back and forth as we see fit, which is actually pretty cool. I'm trying to basically make it so we can wrench on a car. My goal is to make wrenching on the truck or doing a car stream as simple as me like opening my summer car and playing it, and probably less difficult. Right? And Chad calls it the casting couch, Dave. This is just a comfortable couch from my apartment. Brimo didn't like it. I don't understand why. So it got relegated to the garage. So I made a nice cozy corner in the garage and set up a temp streaming setup in here. Yeah. Ain't that a bee? Will you be walking around and peeing as well? Yes. In my house. Thanks for letting us witness the fruits of your success with Twitch. Well deserved. And a ton of fun. I'm glad you like it, man. As in MSC. Dude, it took me a second. I'm like, what? What? I was like, wait, why would you ask me this? No, there will be no walking around and peeing in this. Like I said, this will be easier than MSC. No, the idea is that I could just switch to a car stream like that. I'm trying to make it as easy as basically like if I switch to Car Mechanic Simulator or Summer Car or something. Don't get me wrong, we'll still play Summer Car. Because I in fact don't have a car. Well, I do have a car to wrench on. I don't know if people know this, but the muscle car in my summer car, I have that car. Like it's sitting right out there. It's the one in summer car is the Ferndale. That's a 72 Coronet. I have a 69 Coronet. I have the same car outside with 4 doors and everything. It looks just like it. So I do kind of have the car from Summer Car, but it's not the car from Summer Car, but it is a car from Summer Car. None of the kill you, all the wrenching. Yep. You can have cars to wrench on. Easy, you know, like chairside pee bottle. Been away from MSC for too long. Yep. Starlinks have been yeeted. Awesome. Great. Good. So, yeah, fellas, I might be a little late coming back to Space News tonight. I gotta get to work. So EJ should name his stream setup the Wage Cage. Let's say I'll be back around 8. Let's say 8 I was about to say my summer car. I do not have anything set up. But, yeah. Like, I'm from Poland. I was told I will see it in 10 minutes. The Starlink satellites? Yeah, maybe. It's Friday. Fun. Yeah. I want to get that office done. I've been trying to make a push to get it done during the weekend. But, yeah. Alright, dudes. Did I miss the launch? Yeah, Blunt. It was freaking metal, dude. The landing footage was super crisp all the way down. See you later, dude. Podway, you watch Moonfall. Don't panic. It's mad, but fun too. Alright, right on. Alright, guys. Hey, we'll aim for 8 for Space News. If I don't get to it, I'm going to be working pretty much all night. If I don't get it done, I'll see you guys tomorrow for Space News. But anyway, I hope you enjoyed the Starlink launch. I hope you enjoyed the NASA presser. And yeah.